today, and it's going to be different than our other sections because it's not going to be related to like angle or side or anything of those sorts. It's going to be a different theorem, still about similar triangles. It just isn't proving similar triangles. Okay? Before we get into that, let's do some algebra review. It says factor the following. All three of these have three terms. 1, 2, 3. Does anyone remember from Algebra 1 what we do with three terms? What if I drew this? Would we know what to do? The X method? Okay. I need two numbers that multiply to what? 10, the last number, 10. And we put it on top. And add to 7, the middle number. And we put it on the bottom.
5 and 2.
5 and 2, okay. So 5 times 2 is 10, and 5 plus 2 is 7. What do I do with those numbers now that I have them? Do you need a new packet, Bella?
No,
We should probably just do it. No, don't open the Chromebook. Don't open the Chromebook. Don't do it. Does anyone know what we do with these numbers once we find them in our X? What if I put these parentheses with our variable in it? Now what do I do with those numbers? Yeah, you just add them to your variable. So x plus 5 and x plus 2. I think last year you guys probably called this the X method. It's also reverse foiling because it's like we could FOIL this back out and get the thing that we started with. Okay? Let's do it again for the next one. I need two numbers that multiply to what? 18. Okay? And add to -9. You just got to watch your sign. -9. What are my two numbers here? Let's think about factors of 18 first. What can I divide 18 by? 2. Okay. Can any combination of 9 and 2 make 9? No. Okay, what else? 3. 3 and what? 3 times what is 18? 6. Okay, what combination of 3 and 6 with positives or negatives will add to get -9? Huh? Yeah, we know our numbers are 3 and 6. They both have to be negative for a few reasons. One, because they have to multiply to a positive. So they were either both going to be negative or both going to be positive. That's the only way to multiply to a positive number. And they added to a negative. And two positive numbers can't make a negative. So they both had to be negative. So yeah, like JJ's saying, x minus 3, x minus 6. We could check that if we wanted by FOILing it back out. Questions on that one? Okay, our last one. We need two numbers that multiply to what? -28. Good. Coming from the last term. And add to -3. My middle number. Okay. This one I'm multiplying to a negative. So one of my signs is going to be negative, and the other one's going to be positive. That's the only way to get a negative up here. Let's look at factors of 28. What can I divide 28 by? 2. Okay, so if I do 2 and 28, that'd be 2 times 14. Will 2 and 14 ever get me 3? No. Okay. What else can I divide 28 by? 4. 28 divided by 4 is what? 28 divided by 4?
28 divided by 4
is 7. Okay. Will 4 and 7 ever get me 3? Okay. So one's 4 and one's 7. Which one is negative? if I have to get to negative 3?
7.
7. My bigger number has to be negative because I have to add to a negative number. So we get negative 7, positive 4. And we can factor that as x plus 4, x minus 7. Questions on that one? Okay. I'm going to pull up one of our applications to kind of explain our first theorem. Oh, no. Except for it went away. Give me a second. Okay, so what I've done here is create a triangle ABC, and I put a segment in the, in the middle of the triangle, but not necessarily right in the middle, but inside the triangle. And I made this segment parallel to the bottom side. Let's think, before we do anything, let's think about what we know from this triangle. And I want you to mark this on your paper. This is the same triangle, just shifted around a little bit. I have parallel lines. What we learned in Unit 3 is that parallel lines give me all those types of congruent angles. What two angles, well, let me word it this way. What angle would be congruent to this angle right here? Yeah, angle A, because they're corresponding angles. Okay, what angle would be congruent to angle BED? What angle would be congruent to this purple one?
20, 2.9.
Yeah, the angle C here, the 2.9 is for the segment, but yeah, angle C. Okay, so if we look, just based on what we already know about similar triangles, if we look at this top triangle, we have two congruent angles. And if we look at the bottom one, or the bigger one, we have two congruent angles. Are these triangles similar? Let's think about our similarity theorems. We have AA, SSS, or SAS. Do I have any of those three right here? What are these highlighted parts? Angles. So I have two angles. So my triangles are similar by angle. I'm not going to name my triangles. I could, but we don't need to for this purpose. But just know that my triangles are similar. So that means that if I look at this entire segment here, BA, and I put it over BD, it's going to be proportional to, so if I look right here, BA over BD, that's the left side of my triangle, the blue piece. That has to be proportional to the other side of my large triangle, so BC, over the red side of my small triangle, BE. Okay? We could get that from what we already know about similarity. The theorem that we're going to talk about today takes it one step further. Instead of looking at the sides of the triangle, it actually looks at each piece. So we're going to write a theorem about BD and DA instead of BA and BD. Okay, so we're writing our theorem about the parts instead of the whole piece and the smaller triangle. Okay, so if we look here, again, those lines are parallel. If I move, well, first, if I just look at these ratios that I'm talking about, part over part, AD over BD, and part over part, BC over BE, or BC. What do we notice about these two ratios? Those numbers, what are they? Same, different? They're the same, 0.92 and 0.92. Okay? So now we're taking our similar triangles and we're just extending it a little bit to get information about each piece of our larger triangle. And this works no matter where we put these segments. I can change these lines all around. And as long as these two lines are still parallel, these ratios stay the same. Okay? That's what we call the triangle proportionality theorem. So first, we noticed that these ratios were equal. We had that part over part. So on the blue side, we had, what's one part of the blue segment? What's one part of this? We got to wake up second hour. What's like one part of this side if I wanted to name it with capital letters? Yeah, B, D would be a part and AD would be the other part. So we just learned that AD, one part, over my other part, BD or DB, is equal to my AD part came from the bottom. So I'm going to grab my other part from the bottom, CE. We learned that it's equal to CE over the other red part, EB. And we also learned that no matter how I moved B around, if I made this segment bigger or the red segment bigger, no matter how I changed them, as long as these two lines were still parallel, we noticed that the ratios were still equal. And that brings us to this theorem, the triangle proportionality theorem. This is one that needs to go on your cheat sheet. This is the thing that we're learning today. This theorem needs to go on your cheat sheet. It tells you that if you have a line parallel, the key here is that that line has to be parallel. So we have a line parallel to one side of a triangle. Then it divides those two other sides proportionally. Meaning, we know that BD is parallel to CE. It's what we're given in our picture. We have a pair of parallel lines. Then this parallel line has to divide this side and this side proportionally. What that means is, I want you to write this down and put a big circle over it. This theorem is telling you part over part is equal to part over part. We're grabbing both parts from one of the two sides, and then we're grabbing both parts from the other side. So if we look at this triangle, and let's just say that we color this side pink. Let's look at both parts of the pink triangle, or the pink side. What's one part of that pink segment? CB. Okay, so CB over, what's the other part? BA. So that's my part over part for pink, is equal to, if we look at my other side, right here, what's the part of my blue side that corresponds with CB? It's got to be the part that kind of encompasses that same portion of this triangle. So CB is going to go with DE. I'm grabbing those from the same side of that triangle. So DE is one part. What's the other part of my blue segment? DA or AD, yeah, DA. And we could flip these around as long as we flip both of them around. But make sure that whatever part you put on top, the one across from it is across from it in the triangle, okay? But that's our triangle proportionality theorem. So we're going to use this to find some unknown pieces or missing lengths of triangles or problems that look like this. Before we do any sort of problem like this, you are first checking that the lines are parallel. If the segments aren't parallel, then we can't do anything. We can't use this theorem. So our first condition of that theorem is the lines are parallel. So we need to have these arrows before we tackle any sort of problem that looks like this. So I'm mentally checking in my head to make sure that these lines are parallel before I do anything. So for number 1, my lines are parallel because I have my arrows. Let's look at my parts. If I label this side blue and pink, what is one length or number that corresponds to one of the parts of the blue side? 12's the whole thing. What's one of the parts? 8. Okay, so 8's a part. And my other part is 4. So that comes from the blue side. And now I need to grab my parts from the pink side. If I put 8 on top, what needs to go on top from the pink side? 12, the thing directly across from it. So 12, just like they're directly across from each other in the equal sign in our proportion. So 12 has to go on top, and my other part is x. What method do I use to solve this? What is this, Ella? Yeah, cross product property butterfly method. So our 12 times 4 is 48. Our 8 times x is 8x. How do I solve for x here? Divide by 8. 48 divided by 8 is 6. So x is equal to 6. Questions on that one? I want you guys to try to do this one right next to it on your own really quickly. At least set up the proportion. Put part over part. Okay? And then we can solve it together, but try to set up your proportion on your own or with people around you. Oh my gosh, that's a problem I can fix so easily. The other part of that side of this side. What else is there? That's for this. Why? Okay. So I want you to put 22 over 1. Could have done it the other way too. Now we look at our other side. Our parts are 1. And 10. Which of those go to 22? Which is directly across from 20. So let's put 20 across from our 22. Let's put 10 on the other one. Put an equal sign in between. Cross both. There you go. And then you're good. 21. Okay, for this one, if we looked at the left side first, our parts were 22 and y. So I put part over part. Does not matter which one you put on top or bottom, as long as you keep it consistent for the other side. Okay? Our other side that we need, its parts are 20 and 10. Which of these, out of the 20 and 10, which one should go with my 22? Which one's across from my 22 in the triangle? 20. It's directly across. So the 20 has to go on top. It corresponds with my 22. And then my 10 goes on bottom. To solve, we cross multiply. So 20 times y is 20y. And 22 times 10, when we multiply by 10, we can just add the 0 on. So 22 with a 0 attached, 220. And then our last step would be to divide both sides by 20. And we get 11. Okay? And for all of these, throughout the whole unit, we can check this. We can make sure that 22 divided by 11 is equal to 20 divided by 10. Okay, we can plug it back in and make sure that we're right before we turn anything in. Questions on that one? Okay, this one's a little bit different. And there's more than one way we can solve it. Let's look at parts of each side first. Well, step one, check to make sure the lines are parallel. They are, because we have those arrows. But let's look at each side. What are my parts of this pink side right here? What are its parts? 9 and 3. Okay. What are the parts of the blue side? We have y. Do we have this part? No. Could we find it?
Yeah.
What would it be in terms of y? If the whole thing's 20 and this piece is y, how do I represent what's left?
15.
Not 15,
10.
not 10. We're guessing now. We're just getting smaller, but we're getting smaller by y.
20.
Yeah, we take our whole thing, we subtract off one part, and we get the remaining part. So this is 20 minus y. It might be 15, it might be 10, but we don't know quite yet because we don't know what y is. So we could set this up two ways. We could do part over part for our pink, 3 over 9, is equal to part over part for our blue, 20 over y, or y over 20 minus y. I personally would not do it this way because I have two y's in here and I'm going to have to move them across both sides of my equal sign. Instead, let's back it up to what we initially saw in our first exploration. We saw that the triangles were similar. So now I could use part and part if I wanted to, but if I have the whole piece, I can also use the whole piece and just the part from my small triangle. Okay? So we can adapt our theorem to use the whole side for our large triangle. What's this whole length here?
27.
Not 27. We have to add instead of multiply.
12.
12. Okay, so this whole side is 12. And the whole side, 12, and one of its parts, the part that I need is going to be 3 because it corresponds with my y, and I need to find y. So 12 is the whole thing over one of my parts, so over 3, is equal to my whole thing on this side. What's my whole length on this one? Not 20 minus y, just 20. The whole thing was 20. So 20, and then the part that corresponds with 3 is y. It's directly across from it. So 20 over y. You could do it part over part equals part over part. But if they give you the whole, you can also do whole thing over one of the parts is equal to the whole thing over the other part. Okay? But we solve it the same way. We cross multiply. 20 times 3 is 60. 12 times y is 12y. And then we divide by 12. And we get 5. Questions on that one? Okay. Number 4 here has two variables, x and y. Would it be beneficial for me to do part over part and part over part and have an y over x at some point? No. I don't want to mix those variables unless I absolutely have to. So instead of doing part over part, I'm going to do my whole thing over each part and separate my x and y. Okay? Before we do that, we need the whole thing for this left side. What is this whole segment? 24. 10 plus 14 is 24. So my whole thing, 24, over one of its parts, it doesn't matter which, let's just pick the top one first, 10, is equal to, what's my whole thing on this side? 36. And what's the part that goes with 10?
14.
Y. It's the one directly across from it. Y. We cross multiply. 36 times 10 is 360. We just add the 0 on. 24 times y is 24y. What's my last step to solving this? Divide by 24, we get 15 if you put that into the calculator. So y is 15. Now that we have y, I could do part over part, 10 over 14 is equal to 15 over x. I could do that. I'm not going to reuse this answer just in case it's wrong. It's not, but like on a test, I wouldn't reuse it just in case. So let's use our whole method again. So let's do whole over part. Last time I picked the 10 as my part. What part should I pick this time so I can get my x? 14. Okay, so whole over part, 24 over 14, is equal to, the whole thing for my other side is 36. And we picked 14 because it goes with x. So x is on the bottom. I cross multiply. 36 times 14 is 504. If you put that into the calculator. And then 24 times x is 24x. Last step, divide by 24. You would get 21 for x. Questions on any of those ones using part over part or whole over part? Okay. This next one's just a little more complicated because instead of just having an x or a y, we have a 2x plus 12. But we're going to do the same thing. Step 1, make sure our lines are parallel. They are because we have those arrows. Step 2, figure out if we want to do parts or use our whole. What are we given here? Are the 14 and 16, are those parts or the whole thing? They're parts. And over here we also have parts. So let's use our part over part method. Okay. So if we start with one of our sides, the blue side, Our parts are 14 and 6. So 14 over 6 or 6 over 14, you pick which way. Doesn't matter as long as it matches the other side. So our other side, the pink side, our parts are 8 and 2x plus 12, but which one of those goes with 14?
2x plus 12.
The 2x plus 12, the one directly across from it. So 2x plus 12 on top, 8 on the bottom. We cross multiply, butterfly method. 14 times 8 is 112. And then I also need 6 times the entire thing, 2x plus 12. We have to put that into parentheses. What should I do on the left-hand side with these parentheses? Distribute. Yes, distribute the 6. 6 times 2x is 12x. 6 times 12 is 72. Okay, I want to isolate this x right here. I want to get it by itself. What should I move over to the other side first?
72.
The 72. Let's subtract 72. $112 minus 72 is 40. And now I just have this 12 hanging out with my x. How do I get rid of the 12? Divide by 12. We get x is equal to 40 over 12. Should I box that answer in and turn it in? No, because we can simplify it. What can I divide 40 and 12 by to simplify this fraction? 2. I can actually go more than that. A little bit more. 4. Let's divide by 4. 40 divided by 4 is 10. 12 divided by 4 is 3. So we get 10 thirds. Again, that one worked out the exact same way. We did the exact same process. We just had to distribute into this term right here. Questions on that one? That was the bulk of the lesson. The last piece is just going the opposite direction. We also have the converse of the triangle proportionality theorem. So instead of using parallel lines to set up these fractions, we're going to use the fractions to set up parallel lines. It just goes the opposite direction. So this time, if part over part is equal to part over part, then we have parallel lines. Okay? So for this picture, if A over B is equal to B over C, that's my parts of my yellow triangle, or my yellow side. If that fraction is equal to the parts of my other triangle, goodness, my other side, the pink side, AD over DE. So if part over part is equal to part over part, then my lines are parallel. So then BD is parallel to CE. And again, it's the lines or the segments that kind of connect those other two sides of your triangle where you have your parts. So it's the lines in between your parts. Questions on that converse theorem? We're going to use it in 5 examples, and then we're going to be done. So here, instead of our first step being checking for parallel lines, our step 1 is setting up part over part, seeing if it's equal. Okay? So This question's asking, is CD parallel to EF? So in other words, what we need to check is, does our part over part work? Does BC, that's one of our parts of this pink side, over the other part, CE, is this part over part equal to this part over part, BD over DF? That's the question that we're really asking. Okay? So let's set up what values we know here. What's BC? 72, perfect. What is CE? 30. BD is 96 and DF is 40. So we're asking ourselves, are these two fractions equal? From here you have two options. Option 1, you put the 72 over 30 into your calculator, you get a decimal. You put the 96 over 40 into the calculator, you get a decimal. You see if the decimals are equal. That's option 1. Option 2 is we can cross multiply and see if the numbers that we get are equal. So I'm going to do that method just so we are still using our butterfly method. But if you do 72 times 40, you would get 2,880. And 96 times 30 is also 2,880. So we would say, yes, our part over part was equal to part over part. So are these two lines parallel? Yeah. We would say, yes, CD is parallel to EF by the theorem that we learned on the previous page, the converse of the triangle proportionality theorem. So on your test, there'll be a question like this, and it'll just say, are the lines parallel? And you'll have to know that what that's really asking you to do is check if part over part is equal to part over part. Questions on that one? Okay, 3 more of this type. Again, it's asking if those lines are parallel, so we're checking part over part. If I look at this orange side, what are my two parts? 4 and 10. So 4 over 10. If I look at my pink side, what are my two parts? That's a 5, not a 0.5, by the way. So 5 over 15. Again, I have to put 5 on top because it goes with the 4, and I put the 4 on top for my other one. This one, let's reduce these fractions. I could set them equal and cross multiply. Let's reduce them. 4 and 10, what can I divide both of those by? 2. 4 divided by 2 is 2. 10 divided by 2 is 5. And then for 5 and 15, what can I divide both of those by? 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And these are now both fully simplified fractions. Are they equal? No, they're not equal. So therefore, my lines are not parallel. So our answer is just no. The lines are not parallel. We're going to do the same thing for this one. Part over part. So if I look at this pink side, what are my two parts over here? 4 and 24, so 4 over 24. If I reduce that, what can I divide the top and bottom by? I can divide both by 4, and I would get 1 over 6. And then I'll do the same thing for my other side. What are the two parts of the blue side? 5 and 30. Which one has to go on top?
5.
The 5, because it's across from the 4, and we put the 4 on top over here. So 5 over 30. If I reduce that, what can I divide 5 and 30 by? Divide by 6, or by 5, sorry, and we get 1 over 6. So are my parts over part equal? Are 1/6 and 1/6 equal? Yes. So I can say, yes, my lines are parallel. So PQ is parallel to ST because part over part is equal to part over part. And let's just list those parts. What I did is I grabbed this 4 from SP. So SP over my 24 was PR. So part over part for the pink was equal to my 5 came from TQ and my 30 came from QR. So because these ratios were equal, my lines were parallel. Questions on that one? Second to last one, same situation. We're checking to see if QP is parallel to TS. If we look at this blue side, what are my two parts? 12 and 4. Again, you pick which one goes on top. It doesn't matter as long as you match it with the other side. 12 divided by 4 is what? 3, or 3 over 1. So now I do my other side. What are my two parts for the pink side? 15 and 5. Which one has to go on top?
5.
The 15 has to go on top. Because we put the 12 on top and 12 goes with 15. So I'm going to put the 15 on top. The 5 on the bottom. What is 15 divided by 5?
3.
3, or 3 over 1. So my fractions were equal. Are my lines parallel? Yes. So PQ is parallel to ST. And my reasoning is the same. It's still this reasoning because it's the same picture. I just changed the letters or the numbers. But those fractions were equal. Part over parts were equal. So my lines were parallel. Questions on anything of that type? Okay, we do have one word problem. It says on the shoe rack shown, we have this little triangle that's holding up the shelf that my shoes are sitting on. Okay, I'm gonna just redraw this triangle so I can start labeling the things that it's talking about. So I'm just gonna draw a triangle over here and label it CAE and put a line or a segment BD. Just copy this triangle over. Not perfectly, but good enough. It tells me that BA is 33 centimeters. So I'm going to label BA as 33. It also tells me that CB is 27 centimeters. So I'm going to label it as 27. It says CD is 44. And DE is 25. We have to explain why this line, or this line represents the shelf. So why this shelf is not parallel to the floor. So it already kind of gives us the answer to the question that we were asking in these problems. It's already telling us it's not parallel. So what that means is we have to show that part over part is not equal to part over part. Once we show this, we've done our work to answer the question. So let's look at this orange side first. What two numbers are my parts? 27 and 33. What can I divide both 27 and 33 by? 3. And I would get 9 over 11. For my other side, what are my two parts?
44 and 25.
44 and 25. Which one has to go on top?
44.
44, because I put the 27 on top for my other one. So 44 on top over 25. Can I ever divide 25 by something to get 11? No. 11 times 2 is 22. And it's going to be a weird decimal that I would have to divide by. So these fractions are not equal. It doesn't come out that clean. So it's not equal to 9 over 11. And that's all I have to show numerically. But it says explain. So for my explanation, we could say that BD, our shelf, was not parallel to AE, our floor, because part over part was not equal to part over part. Let's be a little more formal and name the parts. 27 came from CB. 33 came from BA. And that was not equal to my 44 from CD and my 25 from DE. So that's our reasoning, is because those fractions were not equal. Questions on anything about those theorems today? Yeah. Okay, you guys have the rest of the hour, so about 30 minutes to work on homework. At this point, on Big Ideas, all 4 assignments you can work on now. Okay, so 5.0, which I think we've all done, 5.1, 5.2, and 5.3, and 5.4. 5 assignments. And I opened up your second learning check that's due Friday at midnight. I would again highly recommend doing these because I made them, and I'm also the person that made your test. So I would work on the learning checks first. No, next Tuesday. Test next Tuesday, do your learning checks before then.